Hello, everyone. Good afternoon. I hope that you are enjoying the Azure Day Italy. Welcome to my presentation about building an object detector solution with Azure Custom Vision .NET SDK. My name is Luis Beltran. I am a Microsoft MVP in AI and developer technologies. And I hope that this session is interesting for you. So let's get started. Of course, it's good to remember that this event is it's thanks to several sponsors. So we appreciate all their effort, and thanks to them, these things can happen. And of course, thanks to you, because you are the main purpose of this event. So just a brief introduction about me. I am a Mexican, but currently I'm living in Czech Republic because I am doing research at Tomas Bata University in Zlín. I am pursuing my PhD. I'm also a lecturer in Mexico. And well, I am quite interested in Microsoft technology, especially Xamarin Mobile Applications Development, Azure Cloud Technology, and of course, artificial intelligence, which is my main subject of study. Here you also have my email and my Twitter account. Let's get in touch. If I can help you with some of these topics, just let me know. I will be quite happy to assist you. Okay, so this is the agenda. First of all, we will talk a bit about what is object detection. Then let's talk about the Azure Custom Vision service. And after that, let's focus on the steps for building an object detector. Finally, let's showcase these steps, these applications. There are a couple of applications that I would like to show you about this object detection solution, and some final thoughts and recommendations. Let's get started with our topic. Okay, so what is object detection? Object detection can be defined as the process of identifying some elements of interest in multimedia files, such as videos and pictures. This could be compared, or you might think, okay, this is the same as image classification. Well, the key difference is that in object detection, it is also important to know the position of your element of interest in your file. Mainly, this position is through coordinates. Okay, there is a small mistake here. Through coordinates within a bounding box that contains. So you can see in this image that several objects, such as a person or a car, is identified, but also we know the position in this video where this element is located. So, okay, of course, this task for us, let's say, it can be easy because we can, with our eyes, we can easily identify, okay, here there is a dog or a computer, but for computers to actually understand, or for applications to understand, okay, where is this element of interest located? Well, it is not an easy task. It's quite complex in artificial intelligence. But there are several techniques or algorithms that you can use, such as convolutional neural networks or deep learning, or even basic neural networks, that we can train in order to extract the patterns and also the key points that define an object such as a bed. Of course, if we are from data science or artificial intelligence, this is something that we commonly do if we are talking about image classification or object detection. And in the end, after training several layers, we will create a classifier or detector that can recognize objects in our images or videos. Of course, these images that are detected, we should train before, or only the ones that we train, like categories, will be identified later. Of course, we will provide new pictures that we didn't use in training. But if we are developers, what can we use to create such applications? Shall we study artificial intelligence or machine learning or learn about neural networks? Well, Azure provides us several services. You might have heard about them, which are the cognitive services, which you can easily integrate in your application to obtain artificial intelligence capabilities in several fields, such as vision, speech, natural language, and others. For our specific task, we have the Azure Custom Vision service. This service is a customizable web service that learns to recognize a specific content in pictures or even videos. How it works? Well, basically, you upload your own label images, and then you use them to teach this service the concepts that you want to learn, such as a daisy or a flower. After that, after you create a training model, you use REST API calls to tag the images with your new computer vision model, but it's a custom one. There is an Azure Vision service, but which identifies general objects, but maybe you have specific needs. Well, you can use this custom vision service. Active learning is present, so that means that images that are evaluated through our custom vision model become part of a feedback loop. It means that we create the model, then after that we test it with new images. These new images and the results can be used for retraining of our model, or we can tune it or improve it, okay, to get better results each time. Okay, so basically that's the whole theory that I would like you to know. Then let's go a bit to practice. Okay, what are the steps that are involved when you would like to build an object detector solution? Well, basically there are 4 steps. First, you create a project in the portal in customvision.ai. There are several settings that you need to configure. Basically, you choose a domain. That's the most important one. After that, you upload your images. In this case, you need to, upload the images, add a label, and also localize the object of interest. Yes, adding a label is also known as adding a tag. Okay. After that, you train the object detector, and finally, you evaluate. You say, okay, this is working, or I need to improve such accuracy or precision. We can publish and, of course, export the model. Yes, we can do it in the portal, but in this talk, we will talk about SDKs. We as developers can make this process automatic. If we would like to upload 1,000 images, for instance, we are not doing that manually. For us developers, there are several options. We can use the .NET C# language, Python, Java, Go, or Node.js. Of course, also JavaScript. There are several SDKs or REST APIs that we can use to create such object detector, or also image classifier, which is another capability of custom vision service. In our case, of course, we are focusing on the .NET SDK. Of course, if we are creating an application, the very first step is to add a couple of Nougat packages, which actually they compose the .NET SDK of custom vision. These packages are Microsoft.azure.cognitiveservices.vision.custom vision, and then we have prediction and training. Training is the one that we are going to use through this code, and prediction is at the end when we already have a trained model. And yeah, we basically add them to our namespaces. Yes, we have training models, and prediction, and that's it for the start for our code. And then, yes, we will do a very simple task in our portal, which is creating a project. Basically, a custom vision service is organized in a hierarchical way, which means that at the top level, there is a project, which represents the data, the model, and all the parameters that we need for a specific task. We can say that in this part, object detector is also a project. Object detector is a model that we build with custom vision through training images. And it's quite, let's say, easy, because we can go to or visit customvision.ai. I hope that you are watching or looking at the browser. I hope that it is displayed. So we can quickly create new project here, and then we need to set up several parameters, which I will explain with the slides. Okay, so we need, yes, a name for our project, a unique name. Description is optional. Then a resource. Of course, this needs something from Azure. So we are creating an Azure resource. We need a name, which is unique for our local, or sorry, our account. We select a subscription. We create or select a resource group. We set up the location close, let's say, to our customers. Yes, where they are going to use or consume our service. Of course, the cognitive services kind, location, and pricing tier. There is free and standard. We will talk about them at the end of our presentation. And a very important element that we need to also set up is, okay, which is the purpose of our project? Is it classification or object detection? Of course, for this task, we are selecting the second type of project, object detection. After we select the object detection, then something new appears, which is the domain. When we create the project, we are choosing a domain. The domain optimizes the detector to recognize elements from a specific subsets. Basically, we have options such as, okay, if we are going to recognize brand logos, we select the logo domain. If we are going to identify items from retail store, for instance, we select products on shelves domain. And if neither of these domains are suitable for our task, we select the general domain. Basically, what type of objects we are going to recognize? These, the first two are, let's say, pre-trained or are optimized for these scenarios. Just as a side note, for image classification, there are more domains, such as food, landmarks, and retail. But in object detection, yes, there are few. But yeah, it depends. There are also compact versions in the general domain, which are useful when we would like to create a light object detector, which is optimized for systems, mainly mobile, where there are some constraints such as time or processing CPU, right? So we are going to help our object detection model by choosing a domain. In our case, we are selecting the general or compact. Yes, and you can see when we choose the compact here, then export capabilities are enabled. If we would like to export to TensorFlow, Core ML, Onyx, or some other platforms, or also we can export it to Vision AI Dev Kit. In my case, of course, I have already created an object detector that you are going to see in a second. Okay, yeah, after we create the project, we are actually going to visit the settings page, and we are going to obtain three important elements: the key, which is specific for our resource, an endpoint, and a resource ID. These three elements we need to copy and add them to our code. In our code, you can see, okay, we have the name of our project. That is also important or relevant because we are going to find our project by this name. I told you that it is unique. The published model name, we are going to use them later, so don't worry a bit about it. Then we replace, of course, these elements that I told you, custom vision key, the endpoint where we are going to send each request, and the resource ID. After that, we are creating an instance of our training client. So here we have training API. We need to provide API key and endpoint after we create this instance. And with the method get projects async, we are going to obtain, okay, which projects we have in this account. And we are going to get the reference to the project which matches the project name which we set up at the beginning. So of course we are going to talk about Open Images Detector, which is this one, of course. We can rename if we want. And after that, we can also obtain the information about the domain. So we just simply access the domain ID and settings, and after sending a request to get domain async, we obtain, okay, this project is from this domain, and the project type is, yeah, we will obtain it, or you will see it later in the results. So that's the first step. Then, okay, we need to, or I told you that in Custom Vision, we basically upload and tag images. This is the main essence or the main, let's say, food of our Custom Vision service. We need to provide several training images. In this case, for object detection, we are submitting pictures and also the position inside the image, which, okay, if we do it manually, it can be easy, but time consuming. So we would like to automatize this process. For this case, I am going to use the Google Open Images dataset, which is in version 4, but actually I think the current one is version 6, but okay, I am going to use this version 4. Open Images is a dataset which contains 9 million of images which have been annotated. What means annotated? Okay, there is a tag, there is the position or the object bounding boxes, and also some visual relationships like, okay, this image is from sports equipment, but also a bicycle and also maybe bicycle wheel and so on. This data set contains a training set of 14 million bounding boxes for 600 different object classes and more than 1 million images. Is the largest existing data set. Of course, we are not going to use this million of images just as subset. By the way, just some important data or relevant. These boxes have been manually drawn by professional annotators. There are diverse, of course. This is important because when we are producing an object detection solution, we would like, like we are going to use it in the wild, we would like to train the model with relevant pictures that we are commonly going to find like everywhere. It doesn't, if we train a model with very perfect images, like with a lot of light, and then when we are going to use or consume this model, but the images are dark, of course the model will not be suitable. we need to provide images close to what we are going to encounter later. Okay, there should be some consistency. So yeah, it's open. You can download it if you want. As I said, I'm not going to use this million of images. There is a good open source project, which is OID version 4 toolkit, Open Images Dataset version 4, which you can download and run it in your computer. This allows you to download a specific images or a specific, specific images from specific tags. And you can see here, okay, I choose 4 categories. Okay, I would like to get all the apple images, muffins, oranges, and strawberries, because I would like to create an object detector that identifies these categories. So you can see here, okay, I select a small subset, which is the test, but for training, yeah, you can also do that. And this project, with this open source project, when we use it, downloads 2 types of information. First, you can see a group of images per category, but also there is a folder with labels. In each label, you can see, okay, there is this picture, and this this is a JPG file or picture, and also with the same name, there is a text file, and it contains the bounding box that I mentioned you earlier. Okay, there is an apple in this position, X, Y, with weight and height. Okay, there is another apple here, and so on. So every instance of your element of importance is included in this label file for each picture, as you can see. But there is a small problem if we would like to use this. Okay, our Azure Custom Vision service requires normalized coordinates, which means that all our, let's say, this information, these coordinates, should be in the range 0 and 1. It means proportional coordinates. And as you can see, Google Open Images dataset, yes, is normalized, but the toolkit that we downloaded generates denormalized coordinates, which are in pixels. Okay, so I created an open source project in C#, which you can download in this URL, or you can simply go to my GitHub, github.com/icebeam7, and you can see my 3 latest projects. This is one, OID version 4 to Custom Vision, which de-normalizes or simply normalizes the coordinates for its use in Custom Vision. So basically, we are converting these pixels into normalized coordinates with width and height. Also, that's also important because both the Google Open Images dataset and the toolkit have this bounding box in coordinates X and Y, but Custom Vision requires width and height. So there is simply subtraction operation, and we will get the width and height. Okay. So. And in my case, I generate this in a folder which is normalized labels, and you will see them. Actually, you can see them here. Yes, this is what I created. Let's say this is the apple. Yes, these are the pictures, and in this normalized label, we have a text file for each of these pictures, and this is the normalized information already. Yes. And yes, that's it for this part. Okay, we will see this later after we upload them. Yeah, this is what we get. It's very nice. So I will skip for the moment this one. Okay, now what we have here. Okay, so back to our project with the SDK, we get a reference to the tags that are created with get tags async. we can simply obtain the reference and then we create a tag if it does not exist. Otherwise, we just obtain the reference. Since I have been running this project, yeah, the tags already exist. Yes. But yeah, I also create a tag txt file with all the categories that are relevant for our object detector. So the important methods here are get tags to know which ones are already created, and if the tag does not exist, let's create it. Okay. And after that, we obtain or we use the folder where all our pictures are. Yes. And two important elements here. Okay, we prepare the image, and we need to add for each image a region. And you can see here, okay, this is the ID of my image, the ID of my tag, and also the data like left, top, width, and height, the normalized information that I told you. And after I prepare the bounding box for each object in our image, we can add this image file create entry, yes, which get the bytes of the image and also the image regions. There can be several image regions. For instance, in this case, I would say there are 5 because there are 5 apples here, yes, in just a single image. And now for every image, you can see this for each loops. And we upload these images with the create images from files async, but we are going to submit them as a batch. We are not uploading them individually. We are going to group them and upload them as a batch. The batch size maximum is 64. Yes. So we upload them to our custom vision service. So this is the way we automatize this instead of uploading them manually. Okay. So what is the result of this after we train? After we upload the images, the result is this. Yes, all the images from our categories or tags are here, and if I click on one, you can see, okay, there is a bounding box there. Of course, this was obtained with the automatized solution. Maybe let's select this one, and you can see, okay, there is just one strawberry there. Maybe this one. Okay, yeah. Okay, let's go to apples, maybe. Yeah. Okay, this one. Yeah, there. No. Yeah. Okay. In some of cases, yeah, there is only one. But in others, there are several. Yes, bounding boxes there. Yeah. So this is the result. And we need to train the object detector. This is very simple because there is just one single method, train project async. And after we start the training process, we need to evaluate or we need to check the progress. How is it going? We can simply run a while loop, and with the get iterations async, every second we are checking, okay, what is the result? While it is training, we just output this message, and after it finishes, we will exit, of course, this loop, and we will inform the user that the model has already been trained. Yes, and after we train the model, if we say, okay, we agree with the accuracy or with the metrics, we can evaluate and publish the model. For evaluation, we are going to use new pictures, and for publishing, it means that it will be accessible through HTTP endpoints. So that's, let's say, in the SDK, it's very easy because we just call the publish iteration async method, and if we go to the portal, we will obtain this information. Okay, there is an endpoint and there is a prediction key that we are going to use in our client applications. Yes, and for the prediction, let's say it's quite easy because we just create an instance of our prediction client. Yes, and we use the method detect image async. And after that, we just get the top tag. Of course, there will be probability for each of our tags. The top one is the main result. Of course, you will see it in a second. And we can export the models to TensorFlow, Onyx. I already mentioned this at the beginning. You require to select the compact. And after that, in the website, in portal, you can select this, export, select also the platforms, but we can do that in the .NET SDK. We simply use the get exports async and export iteration async with a specific platform such as TensorFlow or CoreML or Onyx or whatever you want. And a file is created. We obtain a download URI. After we download it, you will see some file. Okay, so for this demo, okay, I know the training part takes a lot. So I already have. Just give me a second. I already run this application. I know that time can be a bit problematic, but okay, this is the code which I explored through the slides. Everything that I mentioned there is here. And what happens when we run this program? Okay, first we obtain the information of our Open Images Detector project. And then I told you that we will obtain, okay, the domain, general compact, and also the type, which is object detection. It could be object detection or image classifier. Then the tags, in this case, I deleted previously the tag Apple, sorry. And then it is created, and for other cases, they were there, so they were not created. So it works, it detects that they already exist, no creation. If we want to create another tag that already exists, we will get error. After that, we, let's say, go to our folder where we have the images. And for each category, for each folder, we upload or we add the images with the regions. Here, yes. So every image is like evaluated, and also the labels, TXT files. Yes, so you can see all the images that are compared there. And after that, we can upload them, okay, in batches. Yes. And after we upload them, yes, the training process starts. It takes sometimes, at least, well, in this case, it took around 5 minutes. So you can see all the training there every second. And after this task finishes, you can see the status is completed. Then we publish. This doesn't take too much time. And after that, we can make predictions. So for these predictions, you can see these 3 pictures. Give me a second. These ones, yes. So this was the first picture, and you can clearly see that there is muffin, and with 97%, yes, was detected. There are also some very small detections, maybe the ones in the background. Yes, you can see also the object, the bounding box. Yep. But yeah, the main one was detected. Then we could see another test. This is a second image. And in this case, 4 apples were detected. You can see in the results that there are 4 tags with high probability or high accuracy, yes. And also the bounding boxes here. And then just something minor, which we can discard, of course, because the percentage is small. And the third image is a bit, let's say, complex because there are other or more objects. There are oranges and also a strawberry. And yeah, it has a problem, but it detects because we can see that the accuracy is lower. But they detected, okay, there is an orange here, there is a strawberry, and also some other oranges. But yeah, we can train it. We can add more pictures if we would like. And also, Yeah, I already mentioned this. It is also possible to export. In this case, I'm not using the export part, but yeah, you can check or you can see. I also got this. Yeah, we are almost running on time, but I will show you that you can download with this application, which is open source. You can see there. I downloaded the. Oh, okay, it is not included here, I think. Yeah, I deleted the previous version, but yeah, you can delete the ML model, Core ML, Onyx, and also TensorFlow. And yeah, I already showed you in the portal how it looks. And I also create a Xamarin mobile application, which detects these pictures or images, objects. So this is our last demo. So let me choose, okay, these ones. And let's evaluate. And yeah, you can see there is a muffin there. Just final one, this. And there is Apple. Yeah. In this case, it's a very simple Xamarin application, which sends request. Sorry, this is not the one. To the API, I use the prediction key, URL, and predict request, and I send the request to my endpoint in Azure. And then I okay, if the probability is higher than 30%, okay, let's display it in the result and also draw the bounding box. I use Ski Azure for that. If you are interested, yeah, you just go to my GitHub and you can find the code there. And basically that's it. The rest is just recommendations or some tips. There should be some variety in the images that we are uploading to the service. As I said, you can see several examples there about beer. At least 30 images per tag is needed. Yes. Also include images that truly represent what you will encounter in the real world or detector. Yes. It doesn't make sense to upload very perfect images, as I said, very bright. But for in real application, we will all the images will be dark or not all them. So yeah, we should train against different scenarios. And of course, after we add new images, we can retrain the model. Pricing, okay, there is free version, which you can create 2 projects, and also the training time, you have 1 hour per month, so you can create a POC with this. But if you want to use it for production scenarios, okay, there is the standard version, which has a small, let's say, price of $2 per 1,000 transactions. Also, the images should be stored, okay, so 70 cents US dollars per 1,000 images. And for every computation hour, this means for training mainly, $20. So yeah, it's you can try the service. And yeah, maybe you already know or you are thinking about some scenarios where you can use this product line category detection to identify if some vegetable is rotten or something. And okay, yeah, if you want to learn more about this, you can check the documentations, and also there are some quick starts in Microsoft Learn about creating object detection solution and also using TensorFlow for local offline scenarios. And yes, that's basically it for me. Thank you very much for your time. I forgot to mention, but you can go to my SlideShare. This presentation is already uploaded there if you would like to follow or get all these links. So yeah, basically that's it. Thank you very much for your time. And if there are any questions, please let me know. I will be happy and will try to answer them.
Yes, thank you, Luis, for the session. Yes. There is one question.
Yes.
Is possible to do this in real time? From Leonardo.
Yes, very good question, Leonardo. Thank you very much. Yes, it is possible to do it in real time, even offline. And for that, you will use the export capabilities. You can obtain a TensorFlow model. A second. Yeah, well, I showed. Yes, you can use the TensorFlow, and this will be for offline.
Only one second. I share your screen. Oh, okay. Now.
Yes. Yes.
Okay. You can go.
Yes. Here. Yes. When you export it to TensorFlow, you don't need to send HTTP requests. So your model will be part of your project, and you send all the requests there. So yes, the solution for that, for real time, is to use any of these models. It's up to you which one. If you are targeting mobile Android, you use TensorFlow, or you can even maybe create a Python API which contains the TensorFlow model, and all the requests are sent like in local network or environment. Yes, you can do that.
Okay. There is no other question, only compliments for you.
Thank you.
Andrea, very interesting.
Thank you, Andrea.
So okay. Thank you for the session.
You are welcome. Thank you for having me.
Oh, okay. Bye, Luis. Thank you.
Okay, see you. Have a nice day. Keep enjoying the rest of the sessions. They are very interesting, and congratulations for this event. Goodbye.
Okay, bye.